Imagine this scenario for a second. Your engineering team has just doubled in size over the last 6 months. Everyone is hyped. You're pushing code faster than ever before. But suddenly, the very system that was designed to deliver your software to the world is buckling under the pressure. Your deployment speeds are absolutely crawling. Your cloud costs are creeping up every single month. Onboarding a brand new developer takes days instead of hours. And frankly, your production reliability is starting to look a little bit shaky. Sound familiar? Well, let's dive into this, because if you're building modern SaaS applications on AWS right now, you are going to hit this exact wall. And when you trace the root cause, it almost always points back to one absolutely critical architectural crossroad: your continuous integration and continuous deployment pipeline. Today, we are completely tearing down GitHub Actions and AWS CodePipeline, but we are not doing a basic feature checklist here. This is a deep dive into the real-world, highly practical production trade-offs that you are going to face the moment your application starts to scale.
See, there's a fundamental trap that most teams fall into right out of the gate. They choose the completely wrong CI/CD tool because they optimize for the wrong thing. I've seen this happen time and time again in production environments. Engineering leadership sits down, they look at a slick user interface, they look at the monthly price tag, and they make a decision. But in doing so, they completely miss the fundamental tension at the heart of modern DevOps. The entire conversation boils down to a constant, never-ending tug-of-war between developer velocity and enterprise governance. One of these tools is masterfully, beautifully designed to help your team ship incredibly fast with almost zero friction. The other acts like an impenetrable fortress, giving enterprises total, unyielding control over every single piece of their infrastructure.
And the core of this trap is that most teams don't actually realize which side of that trade-off they're prioritizing until the pain actually sets in. It is so easy to pick a deployment tool when you only have one repository, maybe one simple Node.js API, and a handful of developers. Anything works at that scale. But what happens when you scale from one single repository to 50? What happens when you transition from deploying a simple EC2 instance to managing a massively complex, multi-account Amazon ECS and Lambda architecture? If you prioritize velocity on day one, you might suddenly find yourself drowning in security audits, compliance failures, and spaghetti code configurations. But if you prioritize governance, your developers might literally be pulling their hair out right now, waiting 20 minutes in a queue just for a simple typo fix to deploy to staging.
So let's look at how this split naturally occurs in the wild. Developers, by their very nature, naturally gravitate toward path A, shipping fast. They want tools that remove friction early on. They want to live and breathe exactly where the code lives. And that is exactly why GitHub Actions has taken the entire industry by storm over the last few years. It represents the ultimate pure developer-centric approach. But then you have your platform engineers, your SecOps, your compliance teams. They are looking squarely at path B. They need to control the infrastructure. They absolutely require immutable audit trails, predictable resource consumption, and rock-solid SOC 2 compliance. Let's look at how this developer-first approach on path A actually plays out when you get your hands dirty. Here is a highly realistic GitHub Actions workflow for a modern, Dockerized API. The developer experience here is incredibly smooth. Honestly, it feels like magic the first time you use it. You open a pull request, and instantly, GitHub Actions wakes up. It reads a simple YAML file sitting right there in your repository and spins up ephemeral runners in the background. Because of its native job structure, you can effortlessly fan out and run a parallel matrix test. Imagine testing your application against Node.js 18, 20, and 22 simultaneously across both Linux and Windows environments without writing any complex provisioning logic. Once your test passes, it uses OIDC, OpenID Connect, to securely authenticate with AWS. This means no more passing around long-lived, hard-coded IAM keys that someone inevitably leaks on the internet. It just securely builds your Docker image, pushes it straight to the Elastic Container Registry, and updates your ECS service. It is rapid, it is seamless, and crucially, it is highly visible right inside the pull request window.
This level of integration is exactly why developers absolutely love it early on. Your pipeline is essentially just application code now. That YAML file is version controlled, it's peer-reviewed, and it sits right next to your actual source code. If a brand new developer joins your team on a Monday, they don't need to get access to a separate AWS console, hunt down a pipeline, and figure out how the code actually gets deployed. They just read the repository. Boom, onboarding done. Plus, you have the massive advantage of the GitHub Marketplace, which has over 10,000 pre-built actions. Need to set up a Java environment? Drop in an action. Need to post a deployment notification to a Slack channel? Literally just drop in an action. It drastically lowers the barrier to entry and allows for a rapid iteration cycle that is incredibly addictive for a growing startup.
But here is the inevitable reality check. Developers love this initially until the scaling realities set in. Remember our core framing here? GitHub Actions removes friction early on.
But that extreme flexibility creates massive hidden operational costs at scale. When you start building complex enterprise-grade systems, the very things that made it so fast and easy on day one start to introduce some serious architectural friction. And let me tell you, this gets annoying fast. First, you are going to hit workflow sprawl. That elegant, simple YAML file you wrote, it gets copied and pasted across 50 different microservice repositories. Suddenly, your platform team wants to update a deployment standard, and it means hunting down and manually updating 50 individual files. Then there's a security aspect. Those amazing marketplace actions that saved you so much time, they are third-party open-source code executing with incredibly high-level permissions inside your deployment pipeline. Supply chain attacks are a massive, very real risk here if your organization isn't strictly auditing exactly what those actions are doing under the hood. And as your engineering team grows, you'll inevitably start hitting queue delays on GitHub's managed runners. Your tests take longer to start. The alternative? Managing your own fleet of self-hosted runners on EC2 or Kubernetes, which completely defeats the purpose of a fully managed, hands-off CI/CD system. You end up managing a whole fleet of servers just to deploy your servers. So with all that friction in mind, let's pivot and look at the entirely different philosophy of AWS CodePipeline. CodePipeline does not view your deployment as a simple script triggered by a code commit. It doesn't care about your repository's YAML file. It operates as a deeply integrated, highly structured sequential infrastructure system. A pipeline here is a literal AWS resource. An event happens, maybe a commit to code commit or an image push to ECR. That triggers code build, which is a dedicated, heavily locked down compute environment to compile and test your code. Then, the resulting artifacts are physically zipped up and passed securely through Amazon S3 to the next stage, which uses code deploy to orchestrate complex, rolling updates across your autoscaling groups or ECS clusters. It is linear, it is highly deliberate, and it is fully native to the AWS ecosystem.
This highly structured, almost rigid approach is exactly why enterprise ops and security teams heavily prioritize CodePipeline. Because it is a native AWS resource, it integrates flawlessly with identity and access management. Your pipeline doesn't use external credentials. It simply assumes an IAM role. Every single action it takes, every state change, every API call is logged immutably in AWS CloudTrail. If you need to pass a strict SOC 2 audit, or if you operate in highly regulated spaces like finance or healthcare, this level of governance isn't just a nice-to-have, it's practically mandatory. Furthermore, when your architecture scales and you need to deploy across multiple different AWS accounts, say pushing from a centralized tooling account out to entirely separate dev, staging, and production accounts, CodePipeline handles that complex cross-account permission boundary cleanly and securely right out of the box.
To really understand this philosophical difference, it all boils down to one core technical trade-off: authentication. With GitHub Actions, you are an external entity knocking on AWS's front door. To get in securely, you have to configure an OpenID Connect or OIDC provider. This establishes a complex trust relationship so GitHub can request temporary credentials to perform your deployments. Now, don't get me wrong, it's secure and it's infinitely better than old static access keys, but it requires setup, maintenance, and constant monitoring. CodePipeline, on the other hand, lives entirely inside the house. It just uses native IAM roles inherently. It doesn't need to federate trust with the outside world at all. It simply assumes the explicit permissions you've granted it within the AWS ecosystem. It is vastly simpler and undeniably safer from a strict enterprise security standpoint.
But just like before, there is a massive catch. Platform engineers and security auditors might absolutely love that level of control, but developers, they generally despise the user experience. CodePipeline provides incredible, bulletproof governance, but it can be an absolute nightmare for developer velocity. This rigid structure creates a massive amount of friction for the people actually writing the code every single day.
Let me tell you, this breaks down its scale for the developer experience. Imagine it's 2 a.m. and a critical build fails. To debug it, the developer has to leave their code editor, log into the AWS console, which probably forces them to re-authenticate, navigate through the clunky developer tools menu, find the specific pipeline execution, click deep into code build, and then literally stare at a massive, unformatted wall of text logs just to figure out what broke. The UI is essentially just a big scrolling log file. Also, because CodePipeline is so strict and uses S3 to securely pass zipped artifacts between every single stage, your iteration cycles are noticeably slower. You are paying a heavy time tax for that strict architecture. And setting it up? Forget about a simple YAML file.
It requires heavy knowledge of AWS CloudFormation or the Cloud Development Kit. It is absolutely not something a junior developer can just spin up on a Tuesday afternoon.
If you're enjoying this deep dive, consider liking this explainer and subscribing to DevOps Corner for more DevOps and infrastructure content.
So, synthesizing all of this back together, the real decision usually isn't simply a feature battle of GitHub Actions versus CodePipeline. It's a foundational, philosophical decision about where your team's operational complexity should actually live. Ask yourself, do you want your pipeline configuration to be treated as application code, living in a YAML file directly inside the version-controlled repository where your developers live? Or does your organization view pipelines as critical enterprise infrastructure, requiring them to be codified in AWS CloudFormation or CDK right alongside your VPCs, your subnets, and your production databases?
When it comes down to actually making a practical decision for your team, you need to walk through a real-world constraint framework. First, think about where your source code actually lives. If your entire culture is already on GitHub, Actions is incredibly natural and seamless. But if you have strict requirements to use AWS Code Commit or trigger deployments from S3 buckets, CodePipeline becomes the obvious, friction-free choice. Second, weigh your audit needs heavily. If native SOC 2 compliance and immutable CloudTrail logging are mandatory for your business to operate, you have to go AWS. Third, look at your target complexity. Full-stack developers deploying a basic web app to standard ECS will want the self-serve YAML of GitHub. But if you have dedicated platform engineers orchestrating complex, multi-account, blue-green deployments with manual approval gates, CodePipeline is built specifically to serve them better.
Now, let's talk about the reality of setup costs, because this hits your engineering budget immediately. When you look at the hard data on upfront effort, the contrast is stark. Based on typical 2026 industry engineering rates, standing up a production-grade GitHub Actions setup will cost you roughly $176 to $528 in engineering time. It's incredibly fast. But setting up a highly secure, properly architected AWS CodePipeline, you are looking at $528 to well over $1,000 just in initial engineering hours. Because AWS requires dedicated IAM roles, strict S3 bucket policies, and complex CloudFormation templates just to get a Hello World deployment going, your initial sprint budget takes a much heavier hit. And that financial cost translates directly into your time to production. A competent DevOps engineer can get a robust GitHub Actions workflow pushing code to production in 1 to 3 days. It totally removes the friction early on. AWS CodePipeline, simply due to the unforgiving nature of its strict, decoupled, highly permissioned architecture, will take 3 to 6 days to truly get right and stabilize. This early velocity difference is exactly why aggressive, fast-moving startups will default to GitHub Actions almost every single time. They simply cannot afford the early setup tax and steep learning curve of AWS native tools when they are just trying to find product-market fit.
But you have to weigh that initial speed against the day-to-day maintenance overhead for the next 5 years. Developers drastically prefer the immediate, highly visual feedback of GitHub Actions. Seeing those satisfying green check marks right inside the pull request keeps them fully in their state of flow. But platform engineers? They don't care about green check marks. They need centralized, immutable audit trails. When an incident occurs in production, they want to be able to query CloudWatch and CloudTrail to see exactly what IAM role assumed what permission at what exact millisecond across the entire organization. It's a constant, unavoidable trade-off. You are constantly trading developer UX for enterprise observability.
Looking ahead to the 2026 DevOps landscape, the entire industry is rapidly shifting towards internal developer platforms and dedicated platform engineering teams. We are seeing a massive rise in what we call golden path pipelines. In these advanced, modern setups, we're actually seeing brilliant hybrid approaches emerge. Platform engineers will use heavy AWS tools or highly restricted, centralized GitHub environments to build the core, unchangeable infrastructure. Then, they expose highly simplified interfaces or templates for the developers to actually use day to day. Developer experience is finally recognized as a massive strategic advantage. But at the exact same time, global governance requirements have literally never been stricter.
So, to summarize the real-world application of all this, who should actually use what? GitHub Actions is for GitHub-centric teams who firmly believe that their CI/CD pipeline is just an extension of their application code. It's for teams who desperately need fast iteration, rapid onboarding, and developers who want to self-serve their own infrastructure. AWS CodePipeline is for AWS-centric teams, specifically larger enterprises, who view pipelines as foundational, structural infrastructure. It's for organizations where compliance, cross-account security, and deep native AWS integration simply trump the need for a pretty user interface.
Ultimately,
You can look at feature comparison charts and marketing pages all day long, but here is the ultimate truth you need to take away from this explainer. Most teams don't switch CI/CD tools because they suddenly need a specific feature. They switch because their infrastructure strategy, their team size, and their scaling requirements fundamentally changed. You start with velocity, you hit the wall of operational complexity, and you are eventually forced to pivot toward governance. The real secret is to choose the tool that matches where your organization is going, not just where your code base happens to be sitting today.
If you found this helpful, make sure to like this explainer and subscribe to DevOps Corner for more deep dives like this. So take a hard look at your architecture today. Are you building for the team you have right now or the enterprise you're inevitably about to become?